Hello and welcome to our first Digital Learning Day lesson. Today we're going to talk about section 16.1, and that's solving quadratic equations with square roots. So our learning target of the day is to use square roots to solve equations. All right, now perhaps you guys remember me saying that half of algebra 1 is x plus 1 equals 2, and we just respin the problem, but it boils down to that. And the other half of algebra is x squared minus 1 equals 0. This is where we are now. All the factoring and foiling that we did is so that we have the skills needed to solve equations like that. Now today, we are dealing with the most simple version of quadratic equations, where we're going to work on solving them just by taking the square root. And so that leads to a core idea, something that we have to understand fundamentally in order to do a lot of the things we're going to be doing. And that is the square root of x squared is equal to x. The core idea is that squaring and square rooting undo each other. And so when we do some examples, you'll see how we use that. And then there are two things that we need to know that might be new to you. You may be familiar with this. If we were to look at something like x squared equals 4, you can look at it and be like, well, I get it. X equals 2. Duh. But what's new is that not only will x equal 2, there's an or, x could equal negative 2. So what that means is that we are going to be looking for two answers to all of our problems. So a lot of them are going to have two answers or solutions. The second thing we need to know is that based off of how this works, x squared, what that is, it can never equal negative 4. Because when we say x squared, we're saying x times x. Some number times itself has to equal a negative number. That's simply not possible, because you have to have different signs, and if the number has a different sign, it cannot be equal to itself, and it cannot equal something else, or it can't be multiplied by that same thing to get a negative number. So if we see anything x squared is equal to a negative number, no solution. So those are the two new things we need to know. So now let's do some examples. First one, x squared minus 25 equals 0. Now for today, when we use radicals to solve quadratic equations, we want the squared thing on one side, and we want all of this, anything else, on the other side. So we're going to use a lot of the same tools and tricks we've used before with linear equations. We'll add the 25 to both sides. We now have x squared equals 25. Once we've isolated the term that's being squared, you take its square root, and we're left with 5 or negative 5, because it could be positive or negative. So that's the first example. This one, again, very straightforward. But now let's kick it up a notch. Here's our second example. In this one, we have a binomial being squared. Now, we could factor it out or FOIL it out and solve it that way, or we could realize, wait a minute, this is being squared. I only have a number off over there. I could take the square root of both sides, and the square root and the squaring are going to cancel each other. And so that leaves me with x minus 2 equals 1. Or, because we got to remember, we're looking for two solutions here, x minus 2 is going to equal negative 1. Okay, so now we have to solve these two equations separately. X could equal 3. We add 2 to both sides. And we add 2 to both sides on this one. X equals 1. And so those would be our two solutions to this quadratic equation. Let's do another example. Okay, in this one, we have a coefficient. Looks a little intimidating, looks scary, but we don't have to worry about it too much, because take a look at that number and that number. Those are both perfect squares. And so we go about getting this all over to one side. That will help out. We'll go with 4x squared equals 49. Just add 49 to both sides. Now, if we wanted to, we could take the square root of both sides. However, I'm going to make my life just a little easier right now and divide by 4. So that way because the 4 is not being squared, it's the x that's being squared. I want to get the thing that's being squared by itself. So now I have x squared is equal to 49 over 4. Some of you are going to be tempted to bust out that calculator and reduce that. Don't. Remember, they're both perfect squares. We take the square root of x squared, we'll take the square root of that side. Now here's where we get some fancy math. We'll get x equals, and then what we can do is take this radical and apply it to the numerator and the denominator. And what happens is we get 7 over 2 as the answer there. And we got to keep in mind that's one of the answers. The other one will be the negative of it, so negative 7 over 2. And those are the two answers. All right, I got one final example for you. So this one's similar to some of the ones we've seen before, but again, it's just a slightly different look. Now, what we want to do is get the thing that's being squared all by itself. And so that's the x plus 3. That 2 is not being squared. So in fact, what I will do is divide both sides by 2. And so now I have x plus 3, that quantity squared, is equal to 4. Hopefully by now you can maybe see how we're going to do this. You take the square root of both sides. There's no real thought process on the left-hand side. X plus 3 equals whatever it is on the other side. In this case, we'll have 2 for one of the answers. But keep in mind, we do need 2 answers. So x plus 3 could also equal negative 2. Subtract 3 from both sides. X equals negative 1. Or x equals negative 5. And those are our answers. So to sum everything up, there are 2 things we need to keep in mind. Square root of x squared is equal to x. Square rooting something squared undoes it. And vice versa. If you square something that's square rooted, you undo it. Those are inverse operations. Second thing is we need 2 answers. Or we're looking for 2 solutions. So x squared equals 4 means that x could equal 2 or x could equal negative 2. So anytime we take a square root, we got to keep in mind those 2 negatives. Hopefully this went smoothly. Now you can try the practice problems. Best of luck. If you have any questions, please don't hesitate to email me.